Just by initializing a
So
pointer.
the question is, if we do allocate something here dynamically, what is the limit? Good question. The answer is, so let's clean this up a little bit. And let me restart this counter so I can watch for the time. So let's see. So so this is our free store, right? And I will kind of try to erase some of this and erase this stuff. Okay, so this is our free store. And we want to allocate, this and more and more and more. So we're really starting to allocate dynamically chunks of memory, blocks of memory, which all looks like this. New int, new char, new double, new string. It could be object. There could be a lot of things that you could be allocating on the, in the free store. So what happens is this. On modern architecture, this is a virtual memory. What it means is this, that there is physical memory right here. The operating system is managing this virtual memory for us in such way that when we refer to this particular object, it may be sitting right here. Okay, so it may be mapped to this particular place in physical memory, and this is virtual memory. When we allocate this object, it may be sitting somewhere else. And therefore, for as long as this physical memory is available, this can pretend that it can store much more than it actually appears to be in size in virtual memory, because it is really limited by physical memory. And when you say delete and something gets deleted, of course it goes all the way and notifies the operating system that the memory was deleted. So the physical memory is managed well. But yes, you can exhaust all this, and then of course you're going to run out of memory. By the way, it can be done in a different manner, but also but the simplistic view of this is that if you run out of memory by attempting to say new, what's going to happen is that the pointer here will be given null as a result. So not a real address. So you can basically then say if what I got is null, then sorry, we're basically out of memory. Couldn't do this. That's the case. Yeah. So, but it's because of this virtual memory being a layer on top of the physical memory, all of this becomes, possible, so that we can go to different places in physical memory, and it's only the operating system knows what it's doing with memory. Physical memory is not available to us.
Okay, if you create a pointer, though, if you go back to your code and you get rid of the new, the allocation using the new free store, and you just create a pointer to a character, and you start using it like it's an array, like you were doing earlier. How risky is that?
It's very risky. It is very risky. I mean, it's just you really should know what you're doing, but perhaps it's a really bad style. Maybe you're trying to do something strange. I don't know, but at the same time, compiler just really doesn't know. I mean, we can continue doing this like this. We could potentially say, while true, like forever, right? Forever. We could now say, we could do something like this on one line. Cout print chrr, and we can. Well, I still need some sort of an int. Let's do this. Okay, so here's the loop, right? And it ends right here. An endless loop, and I'm just going to say plus chrr, right? And just print chrr and essentially dereference it, right? So it's a runaway train, right? So we just, okay, we know that some block was allocated, but we just let it run like that. So a compiler doesn't realize that this is a runaway train. It will compile the code, which will be incrementing the pointer and basically trying to talk to cout and saying, look at this address and could you please print it. So in this case, obviously we are going to crash, and it's going to happen. And after, in fact, in this case, the debugger or the debug version of our program was designed pretty well. So I'm just going to say abort, and look what happened. We're so what happened here was where is it? Knew how many blah blah blah. So we were able to print. I'm just trying to.
Well, if you hit ignore, it would have printed more, right? If it just ran.
I'm trying to understand where. Apparently.
Didn't even get to.
Let me try this again. There's some garbage. So let's just say cout like a checkpoint 1, right? And then just for the sake of the argument, cout checkpoint 2. So we're basically clear where we are. So build that.
So that's how you put work.
That's how you debug, right? Right. Yeah. I never got to print this. It says.
It's not even getting.
Well, it's saying you're using data without it being initialized.
Yeah. I am trying. Yeah, I should probably clean this up. Yeah, it's this. It's right here, right? It's right here. So let me not go that way. Let me not print any of this. Okay. So really to just clean it up a little bit and yeah, I was suspecting that. So let's see. So it printed quite a bit of garbage and then it stopped, right? So it went to print checkpoint 1, and this is how many characters it was able to dump from that free store. Obviously, it did go to this free store and was able to kind of scan through it, but eventually someone noticed that you're no longer in the area of memory which still belongs to you, and soon enough it stopped. There was a memory access violation. So yeah, so that's the case. All right. You know what? Let me save this.